Hey everyone, Geophysicist Stefan Burns here. We have just seen an explosion of activity on the sun from a new sunspot group. This is 4366. It is becoming extremely active. It is growing very rapidly and it is quite compact and dense. This is now rotating into view, but it basically just started forming in the last 36 hours. We have not yet seen any M-class or X-class flares yet from this sunspot group, but I think that is going to change over the next couple of days as it gets closer and closer to Earth's center and direct, because this sort of extreme electrical activity that we see where it's just really going off non-stop, that is almost always a clear sign that we have something big coming. And now this sunspot group is quite large. It is now capable of producing those sort of big M-class and X-class flares. And if it continues to grow at the rate that it has, we could be looking at some big solar activity after the full moon, which is tomorrow. So it'll be Earth center and direct around the 3rd, 4th, 5th of February. So we have a little bit of time before then, but even if it gets to approximately here, which would be around the 2nd of February, the 3rd of February, and it starts blasting off big solar flares and coronal mass ejections, we could have some solar storms inbound, and I think that is likely. So we've had a little bit of a break after that really extreme solar storm impact that we had back on the late 19th of January and 20th and the 21st with that G4 geomagnetic storm that even spiked up to a G5 minus level at some points. It was a S4 proton radiation storm, the strongest in 23 years. I've talked about it a lot. Well, we've had a little bit of time now to integrate and work with those energies. Things have cooled off. The solar wind is looking fairly normal right now in terms of its overall parameters, magnetic field, density, velocity, but it looks like that is about to change. So with that, let's get right into it. The 131 angstrom imagery that we just looked at really shows the explosive activity of this sunspot. We're going to look at two different views though, so you can really see just how dramatic this is, because looking at the different views of the sun really helps you understand what's happening. This is our intensitygram. Check out just how quickly those sunspots are forming. Each dark zone there is a zone of extreme magnetic flux where the magnetic fields are hyper strong. This is not just 1 or 2 Gauss, but like 2,000, 3,000, 4,000 Gauss in strength. For reference, Earth's magnetic field is 0.23 to 0.67 Gauss. So in these sunspots, you get extreme magnetic flux density, really powerful electric fields, very complex dynamics with the plasma. And if you have this big clustering of sunspots, that makes them very unstable. And well, that's probably one of the craziest sunspots that we've seen quickly develop on the sun in this entire solar cycle 25, and during this solar maximum. Honestly, I think in 1 or 2 days time, this is going to be really big news, though we are catching it early and I'm informing you all on the channel right now. So this intensitygram is really clearly showing what is happening in the preliminary stage for the sunspot before it likely blasts off some big M-class flares. And I'm thinking we're going to get some X-class flares. And the reason I think that, to be honest, is that I'm about to embark upon a snow camp up in northern Sweden. And one of the points of the trip is to see the aurora and everything. And when I was talking to my buddy Rob, one of the event planners and one of the hosts of that, the day before I talked to him, I had this incredibly vivid dream of seeing the aurora. And well, that starts on the 3rd of February. So this is perfectly in time for my snow camp, which is a trip based around survival, but also aurora photography. And well, here we go. So take that for what it's worth, but we have some activity right now on the Earth-facing side of the sun, and we can also see this again with a new angle with our 171 angstrom imagery. Let's give it a look. Now to me, this 171 angstrom imagery is the most insane of all of them. Now what we're looking at with all these different views of the sun are different features, and we can't, for example, look at 131 or 171 angstrom imagery from the surface of the Earth, because this is extreme ultraviolet light that we're looking at, and that gets absorbed into the atmosphere. So we didn't start being able to image the sun like this until, I believe, Skylab in 1973, and we got our first EUV imagery of the sun. And different wavelengths show us different features of the sun, the corona, and then deeper into the chromosphere, photosphere, all these different layers of the sun, whereas an intensitygram shows you the sunspots itself, which is what we just saw. Check out our 171 angstrom imagery here of sunspot group 4 4366. I mean, it's just looking so absolutely nuts. Oh my God, that is crazy. That is not something that you see every day. We have been seeing it more with solar maximum, of course, because during solar minimum, you have very little sunspot activity. It's not uncommon for there to be long stretches where there's 0 sunspots on the sun at all. We're right now at the end of solar maximum, the beginning of the descending phase, that boundary. And well, this is a sort of activity that is typical to solar maximum. Rapid sunspot growth, extreme activity from those sunspots, compact clustering of those sunspots, a lot of magnetic flux to that region. And well, typically with all those there, checked all the boxes, that is usually a sign that there's some big solar flares to come. And so that could happen sooner rather than later. Perhaps we get some big solar flares here, and what launches off only minimally grazes the Earth with like a flank impact if there's a coronal mass ejection. Of course, the light flux will travel in a straight line, hit us, energize our ionosphere, can trigger radio blackouts. An X-class flare will trigger an R3 radio blackout or stronger. But if there's a little bit more time for it to grow and it remains very active like this, but without blasting off a big solar flare, then by time it gets this more Earth central direct region and then it decides to go, we could be looking at something really, really big. Just based off of the imagery that we have thus far, the data that we have thus far, let's look at our X-ray flux so you can see specifically this ramp up that I'm talking about. Here we're looking at a measure of X-ray flux from the sun as measured in geosynchronous orbit at 5.6 Earth radii. And so we see that our X-ray flux was flat because sunspot activity on the Earth-facing side has effectively been very, very minimal over the past few days. But now we can see how it's been ramping up steadily. We're only in the C-class range right now, but it is effectively showing this increase, and we haven't had a big flare. So the moment we get a big flare, it'll immediately bump up to M-class or X-class. The fact that we're forming this strong base in the C-class zone is a sign that that's very likely to come. I'd put that percentage at probably about 80% or so over the next 48 hours. And then you go further out than that, I think that percentage bumps up even more based off of the growth, that rapid growth of that sunspot group. So here's our 7-day. We see how things started to cool off after all that activity back on the 18th, 19th, and 20th of January. That time zone, we were having a lot of activity from the sun, big sunspots. Then things got calm, but now they're ramping back up. And we do have some sunspots that are on the far side of the sun. Let's check them out. So this is not our typical way of looking at sunspots on the far side of the sun. We usually use helioseismic data for that, but right now the helioseismic isn't really showing much, and that is still a useful data point. But we have another way, and that's by using the mass cam on the Mars Perseverance rover, which every day typically will point up and take a photo of the sun. And this is very beneficial to us when Mars is on the far side of the sun like it is right now, allowing us to get a low resolution look at what's happening on the far side of the sun. So you'll notice a whole bunch of hot pixels there. These are just noise artifacts. You can ignore them. But here we see a little bit of discoloration, and also there a little bit of discoloration on the sun. So we do have two sunspots which are large enough, though they're being picked up in low resolution, to even be first observed and identified by a rover on the planet of Mars, which remember is further out from the sun than the Earth. So these must be fairly significant to show up. If they were really big, of course, they would show up even larger. We also have a little bit of discoloration there. So we do have all those sunspots which were giving us a lot of activity just a week, 2 weeks ago, now on the far side of the sun. They will be rotating back into view over the next week or two. That's the typical flow, about 28 days to do a full rotation. So we're definitely not done with solar activity in 2026. We still have a long ways to go. And right now with this new sunspot group having formed rapidly, 4366, that is adding more dynamics into all of this, because often we'll have these periods of solar activity where it's from a fixed sunspot group, it formed, it's developed, it's there, it goes through multiple rotations, but we don't get new solar flux to push out anywhere as kind of an X factor element. Well, 4366 is now that new X factor because it is rapidly grown, it's very compact, very dense, and I think it's going to be even more active than it already has been. It's only been about 36 hours, but I think we are looking at M-class flares and X-class flares over the next few days at a minimum. Now, something I like to point out is our cosmic ray flux. And what we see is that during solar maximum, we have a reduction in the amount of cosmic rays that are received here on Earth and in general across the entire solar system. A cosmic ray is a very high energy particle from beyond our solar system because in general, the galactic environment, the cosmic environment produces a lot of extremely high energy particles. These are like God particles, you could say. There's a whole super wide range to their energy density. In general, the faster a particle is moving, the more energy it has. So the closer they get to the speed of light, the energy density goes up tremendously. Well, during solar maximum, the overall heliosphere of the sun strengthens such that it redirects a lot of these cosmic particles away from the solar system, and specifically the inner solar system, because while they're traveling close to the speed of light, they are still particles and therefore still governed by electromagnetic fields, whereas a light photon just travels in a straight line. It's unaffected by all of that. So here we see that solar storm that came in right there on the 20th of January. This is called a four-bush decrease, where we have this massive drop in cosmic ray flux because that coronal mass ejection is so strong, it swept out our local interplanetary neighborhood, you could say, of any cosmic flux and particles that were streaming through and existing. So we had about a 20% decrease. Here's our past 24 hours. It's been flat. You can see that we've gone back to effectively where we were, though slightly lower. But here we see our data going all the way back to 1964, April 1st. And here is our present day. So we see that we have higher cosmic ray flux during solar minimum. That's when we'll have the most amount of this cosmic energy coming in, that particular type of cosmic energy. And then during solar maximum, it's at its lowest. Well, look here. With where we are right now, we're definitely at a much lower cosmic ray flux. We're in a much lower cosmic ray flux environment now than we were during the maximum cycle of solar cycle 24. And also, honestly, we're having levels quite a bit lower, I would say, and for a longer duration, right, in general, than solar cycle 23. Because a lot of solar cycle 23 hovered here at about -5. And we're really kind of getting close to -10 and staying there for a while. So, there's a lot of similarities between solar cycle 23, solar cycle 25, which is what we're in right now. You'd have to go back to 22 to get an environment where the cosmic ray flux was lower, and that's back in the early 90s. So this is significant. I wanted to mention this because while more solar energy is hitting us and interacting with the Earth, there's also this reduction in cosmic energy, specifically these high energy cosmic particles. So there are, of course, other ways that you can measure cosmic energy flux. This is, for example, gamma ray burst or, 3i Atlas, the fact that we have an interstellar object in our solar system right now, giant radio flares and bursts, and so much more. But this is an important one. So if you've been feeling different now as compared to, let's say, 2018, 2019, 2020, 2021, this could be because there's been a big difference between the solar flux and the cosmic ray flux. And with this new sunspot group being very, very active, we could get another big four-bush decrease if another big solar storm sweeps by the Earth. And well, I think that's likely. And here we have our daily estimated sunspot data for the past month. And so we see here our average with the blue line. We're right just under 120 sunspots on average for the month. Our average for December was just slightly more than that. We'll look at that data next. But you see that we go through these cycles here where we have a low sunspot number and then a high sunspot number. And this is because in general, the sunspots are not homogeneous across the entire surface of the sun. They seem to cluster in general on one side versus the other. So when that side that has no sunspots faces us, or rather about 50 sunspots, we have this drop, and then it charges up when we have that big sunspot region rotate into view. As of right now, we do not track sunspots in terms of the sun across the entire sun at once. We're simply tracking sunspots on the Earth-facing side in a significant way. I know it's crazy, but we don't have enough probes to do this accurately. Hopefully that gets changed by the time we go to solar cycle 26. but you see that we're starting to go up and that our base that we formed, where we didn't drop down all the way down to 50, we only dropped down to slightly under 100. So there is this kind of uptrend that is clicking in right now, and sunspot group 4366 is a big part of that just because of how many different sunspot cores are clustered together within that active region. And here we have our monthly sunspot count. Going back to solar cycle 24, we see that we did not break 150 for our monthly count with that past solar maximum. Then we went down to solar minimum in 2020, started to ramp up. Solar maximum really is basically this zone right there. We see that with solar cycles is that there's this quick ascending phase, and then you've kind of formed this broad plateau of activity. There will be variation within it, but then you'll notice that there will be this break of that plateau and then you drop back down. That's the case with a lot of different solar cycles. And while we see that this is our ramp up right here, we broke out of that pattern. This is our solar maximum. We're right now still at the bottom of that pattern. Until we break below that, I'd say that we're at the end of solar maximum and the beginning of the descending phase. So the sunspot count for January is going to come in slightly lower than December, which was 124. We're going to come in probably about 120 or so. So we haven't broken down out of that, but I'd expect by probably April or so, I think this is going to be quite a bit lower, but we'll have to wait and see. But that is where we are right now. So the next few months could be some of the last big months for sunspot counts. That does not mean that we can't get big solar flares, solar storms, geomagnetic storms throughout the descending cycle, but it'll probably just be from one big sunspot cluster that forms, rotates, does a big blast off, that type of deal. Right now, the flux is more distributed across the entire sun because there is this flip of the magnetic field that's ongoing, though the polarity is starting to now emerge in a more reverse direction than it was with the last one. So it is important to note that at the center of our solar system, our star, the sun, 99.86% of the mass undergoes a magnetic field reversal every 12 years on a human time scale. You think that maybe because this is at such a big scale, this would be at like a cosmologic time frame or like geologic time, for example, like every 10,000 years or a million years it does a flip. It does it every 12 years. So this is something that we can really connect to and feel. Perhaps that's the whole reason why it does it so quickly. There's no reason why it should, right? If the star's been around, the sun's been around for 4 or 5 billion years, why does it have to do a flip every 12? Makes you think a little bit. But this is something that completely affects everything in our solar system in terms of the light, in terms of the overall electromagnetic field, the heliosphere, how that charges up all the planets, how that interacts with us and our energy environment and consciousness and more. So if you feel like you've undergone a flip from 12 years ago, well, you wouldn't necessarily be wrong because the sun has. And if the sun can do it, then you certainly could also be feeling quite a bit different than you did 12 years ago, or even just, let's say, back in 2020 when it was solar minimum, when things are very stable. Now things are very unstable with the sun. In general, that means instability here on Earth with society and civilization and politics and geopolitics and financial and economic systems. There's more revolutions and things of that nature during solar maximum. In general, more societal unrest and these social movements unfold during solar maximum. So that is all something that you can research into. I've talked about it a lot on the channel. I'll link a video in the video description that you can watch to learn more about that. But expect for the rest of 2026, now that we've gone through a lot of solar maximum, that energy has entered into our Earth energy system for it to really begin exerting an effect. Because there is also this loading aspect. When you're at the beginning, it's the wave just starting to come in. Now the wave is crashing and everything is tumbling. So that's where we are right now. So that's it for today's video. I've been your host, Stefan Burns. Thank you all so much. I will keep you up to date with everything that's happening with our sun and here on Earth, of course, with our stellar environment as well. So if you like the sound of that, then please subscribe, smash that thumbs up button to help this channel grow. I think we have some big activity coming in, so I will keep you up to date as I can as I go into this snow camp. I do have an X account that's at Stefan Burns Geo, where I release updates in between videos, and I expect I'll be doing more tweets during snow camp than I will be doing videos, but I'll keep you up to date as necessary on any important news that is unfolding. That is my promise to you. So thank you all so much, wishing each and every single one of you well. Please take care of yourselves. I'll see you all in the next video.